practice this one. So this says, how many milliliters of water are made in the combustion of 9 grams of glucose? And I give you the formula for glucose. All right, so what am I looking for? I want the milliliters of water. That's what I'm looking for. How many milliliters of water? And what did they give me? They gave me 9 grams of glucose, and they told me the formula. So let me write out the formula instead of the words. And that's it. I'm looking for milliliters of water, and they gave me grams of glucose. So let's look here. I've got grams of glucose. I want milliliters of water. So let's ignore the units and just notice I have one thing. I'm trying to go to something completely different. So how do I go from one thing to something completely different? What do I use? I use stoichiometry. I use a balanced equation, those coefficients. So that means I need a balanced equation. So then I have to know, well, what's going on? So this says it's combustion of glucose. So we've already kind of practiced combustion a lot. So at this point, you should kind of know what it is. It's whatever's being combusted. So we write that down. Plus O2 goes to CO2 and water. This is combustion. And we're going to write it again on the slide when we talk about different types of reactions. All right, so now we need to balance it. What elements do I have on the left? I have C, H, and O on the left. On the right, I have C, O, and H. So just write them out. How many carbons on here? I got 6 carbons. I have 12 hydrogens. And then I have 6 oxygens here. And I have 2 oxygens here. So that's a total of 8 oxygens. How many carbons here? 1 carbon. Okay. 2 hydrogens. Oxygen, I have 2 from here. And 1 from there. So it gives me 3 oxygens. All right, so let's see what we want to balance. Anything that's not CH and O, well, that's all I have. Okay? Anything that's not by itself. Oxygen's by itself, so I want to do oxygen last. So let me just start with the carbon. All right, so I have 6 here. I have 1 here, so what side needs to go up? This side needs to go up. So I need to put some number here to get 6. So some number times 1 gives me 6. So what would that be? A 6. So now I have 6 carbons. But now I messed up the oxygens. Instead of 2, now it's 6 times 2, which is 12. So I need to change that number to a 12, which means now my total is going to be 13 instead of 3. All right, so carbons are good. We said we do oxygen last, so now let's do hydrogen. I have 12 here, I have 2 there. So what side do I need to increase? That side. And it's only in one spot here. So I need 12. So what number times 2 gives me 12? 6. 6 times 2 gives me 12. But now I messed up the oxygens here. Now I have 6. So this number is going to change to a 6. Still have the 12 from this side. So now I have 18 oxygens. All right. Now let's see. I have carbons are good. Hydrogens are good. Let's do oxygen. I have 8 oxygens here. I have 18 oxygens here. So which side am I going to change? This side. Okay, so I want this side to go up to 18, but I have them in 2 spots. So do I put it here or do I put it here? If I put it here, I'm going to mess up the carbons and the hydrogens. So I want to put it here so I only change the oxygens. So, but I got to remember it's in 2 spots. So it's not that I want this whole thing to be 18. So it's not what times 2 is going to give me 18, which would be 9. Because if I did 9, then I got the 6 here, and it's going to be too much. So if I have 6 here, I want the whole thing to be 18. I got 6 here. How many would be on this side? 12. Okay? So then how do I get 12? What number goes here to give me 12? 2 times 6 gives me 12. So I put the 6 here. 6 times 2 is 12, plus 6 more gives me 18. So now everything is balanced. Carbons are balanced, hydrogens are balanced, oxygens are balanced. So I do a quick check. 6 carbons, 6 carbons. 12 hydrogens, 12 hydrogens. 6 oxygens, 6 times 2 is 12, so that gives me 18. 6 times 2 is 12. That gives me, 6 times 2 is 12. 6 times 1 is 6. 6 and 12 is 18. I didn't have to multiply by a factor because they're all whole numbers. So sometimes that happens. All right, all that to get my balanced equation. Now I can actually do my problem. Because I had to do all this because I'm trying to go from one to the other. And the only way I can go from one to the other is I need these coefficients. So I have 9 grams of this guy, but I want the mils of this guy. So I want to go from one to the other. So I want to go from here to there. What units do I need to go from here to there? I need it to be in moles. This isn't in moles. This is in grams. So what I need to do first is I need to change him to grams. So I have 9 grams of my glucose. I want to go from grams of my glucose to moles of my glucose. How do I go from grams to moles? The molecular weight. I add it up on the periodic table. So I say 12 times 6 plus 1.008 times 12 plus 16 times 6. I add it up. And I add it all up, I get 180. Is 180 going top or bottom? Bottom. It always goes with the gram. So 180.06 and 1. So grams go away. Now I'm at moles. So now I'm in moles. Now I can go to my other guy. Moles of my glucose on the bottom, so they cancel. Moles of who I'm trying to go on top. All right. So what numbers do I put here? I'm going from moles of one to moles of the other. I'm changing from one guy to another. So I need to get those from the coefficients. So this number here is understood 1. This number here in front of my water is a 6. So this is my stoichiometry. This is the new thing right here. Going from one thing to another in that multiple ratio that comes from the coefficients of my equation. So now I'm in water. But am I done? I want water, but I want milliliters of water. Well, how am I going to do that? So let's think about it. I have moles, I want milliliters. Moles is kind of like a mass. So how do I go from a mass unit to a volume unit? What relates mass and volume? Because they didn't tell me anything else in the problem. So it's got to be something I just know off the top of my head. So to relate mass to volume, that is density. So my density relates my mass over volume, remember? So if it's water, what is the density of water? That is 1 gram per milliliter. So if that's 1 gram per milliliter, my volume units match, but my mass units don't. These are in moles, and my density is in grams. So I need to convert these moles to grams. So moles of water need to go to grams of water. How do I go from moles to grams? The periodic table, the molecular weight. So 2 times hydrogen is about 2, plus oxygen is 16, so that's going to give me 18. Does 18 go on top or bottom? It's going to go on the top because it goes with the grams. So my 18 grams on top, my 1 mole on the bottom. So moles of water cancel. I have grams of water, but I want milliliters. So now I can use my density because my units match. This is in grams, this is in grams. This is in mils, this is in mils. So the mass goes on the bottom, the volume goes on top, and since the density is 1, it's just a 1-to-1 ratio. So now I just do the math. 9 divided by 1.180 times 6 times 18, and then that's just a 1. So when you do all the math, you're going to get 5.4 milliliters of water. And that is it. Okay? So that's how you go from one thing to something completely different. Now, on the next lecture, we're going to talk about, so far we just talked about going from one to the other. But what if I have some of this and some of this, and I want to know how much I'm going to make? How do I figure out how much I'm going to make if I know how much I start with of all like kind of my beginning ingredients? Say I'm trying to make like cookies and I have all my ingredients. How many cookies am I going to make? that's what we're going to talk about in the next lecture.